In the previous classes, we start with random walk, and then from random walk we give the concept of Markov chain. The Markov chain which has some property which follows by the random walk, and this is more general. Random walk is just a special case of Markov chain, the example of Markov chain. There are several examples. Also, random walk, maybe two-dimensional random walk, any restricted random walk was there. So we'll talk on that later. We just deal with a random walk on the real line, on the integer, on the integer. Now then we find the distribution of xn. Actually, in Markov chain we know the distribution of conditional distribution, but from conditional distribution we find the joint and marginal using the conditional and this conditional distribution and initial distribution. This is the conditional distribution, which is known as transition matrix. So it is x to y. So it is from x to y. This is called transition probability. And transition probability, which gives, if it is a finite state space, then it is give a matrix which is called transition matrix. From there we define Px, the probability of some event start at x, probability of that something which is start at x, xn at x. This something is, say if it is y, then it is probability of xn plus 1 equal to y. Maybe some event there, say maybe this some a, then it is probability of xn plus 1 belongs to a given xn is equal to x. So start from x. We forget all the previous thing. We start from x, xn. So that is actually the, we can consider that as the initial distribution. That starting is xn. Okay, let's start at xn. We start x. Now time is 0. Say we can just rename this. We say xn equal to y0, xn plus 1, then y1. We forget the previous all this thing. We find the joint distribution, then in using initial, and then state space, define state space, and Markov chain with two state. Markov chain with two state is important in this reason that this information is a working and non-working state. So, and we find the limiting distribution of this marginal, limit n tends to infinity, limiting marginal distribution. We find that is by q by p plus q, and limit n tends to infinity, probability of xn equal to 1 is q by p plus 1. Remember, p plus 1 not equal to 1. P plus 1 not equal to 1. So today we start with Markov chain with more than two states. So it's a Markov chain with d plus 1 state. The state space is say 0, 1, 2. It may be anything, but we just rename this to d for simplicity. Now, what is the transition function? Transition function from x to y is actually its probability. So, it's a function is take two values from the state space. So it is a 0, 1, 2 dot 3 whole square. So partition product P. So it take two values, ordered pair actually, and give output at 0, 1 because it is probability. This is a transition function. Now transition function can be thought as a matrix. We can thought as a matrix, something like that. Say it is 0, 1, 2 dot dot dot, dot D and 0, 1, 2 dot 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 D. So here we write P 0, 0. So 0 to 0. Next we write P 0, 1. So remember, it is not 1, 0, it is 0, 1. So 0 to 1. P 0 D. Similarly, P 1, 0, capital P, P 1, 1, 1 to 1, then P 1 to D. The last row is P D 0 from D to 0, D 1 dot 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 P D D. Remember, in column side, this is starting and this is the initial, the terminal. From this, X is here, Y is here. This will be P X Y from X to Y. So row wise, the 0 from the xth row to x plus 1th row to y plus 1th column. From to get the from 5 to 7, we have to find the 6th row and the 8th column element. Now this matrix actually gives the whole scenario. We know the transition. Once we know the transition function, we can find the joint, marginal, everything, because these are conditional distribution, conditional probabilities. Now this matrix gives everything, and from this matrix we can find joint and marginal distributions. Now we need a initial distribution. So initial distribution is a like a vector. Initial distribution. Initial distribution is a vector. What is initial distribution? So it is pi 0, 0. Start at 0. Pi 0, 1. Distribution is pi 0. Dot, 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 pi 0 d. And this take as a vector d plus 1 row vector. It is a d plus 1 row vector. Row vector. So this is the initial distribution. By the order of matrix is d plus 1 cross d plus 1. Now, what is the distribution of x1? What is the distribution of x1? Remember, this pi 0 is nothing but this is probability of xn, sorry, x1 equal to 0 or x0 equal to 0. Then x0 is equal to d. Now, take pi n, let pi n be the distribution of xn. The matrix pi n, we can say this vector as pi 0. Pi 0 is the vector. The component is pi 0 I. The I plus 1th element is pi 0 I. Now, pi n is the vector which describes the marginal distribution of xn. What is this? This is probability of xn is equal to 0. Dot, 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 probability of xn is equal to d, d plus 1. Now, you can easily find that this pi n plus 1 is nothing but pi n into p. Why this is so? Why this is so? This is because, okay, pi n p. What is pi n p? This is p probability of xn equal to 0. Dot, 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 probability of xn is equal to d into this matrix, this whole matrix. This prob p 0, 0, p 0, 1, p 0 d, p 1, 0, p 1, 1, p 1 d. P means probability, sorry. Prob Probability from 1 to D. See, this function is called P, but this, we say P D1, D0, but we say probability from D to 0. P D1 dot P D. Now, if we want to find the, say, if we want to find, say, some element, some I plus 1th element, what will be that? I plus 1th element. We know the first elements come from this row, this P probability of xn equal to 0, xn equal to d, with the multiplied with the first column. It's like a dot product. Now here that means to find I plus 1th element, we need I plus 1th column. We need I plus 1th column and take the dot product. So what will be this? This I plus 1th element. This I plus 1th element is probability of xn equal to 0 into P 0 I plus probability of xn equal to 1 P 1 I plus dot 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 probability of xn is equal to d into P di. What is the meaning? Meaning is actually start at xn. This is what? This is probability of 0 I. What is P 0 I? P 0 I nothing but this is probability of xn equal to 0 into probability of xn plus 1 equal to I given xn equal to 0. Similarly, the other. Now, what is this? This is probability of xn is equal to 0 and xn plus 1 equal to I. What will be the next term? This next term will be probability of xn equal to 1, comma, intersection xn plus 1 equal to I. So xn equal to d, comma, xn plus 1 equal to I. Now what is this? This is just probability of xn plus 1 equal to I. Because if you take the union, these are all disjoint. Xn equal to 0, xn equal to 1, these are cannot hold together. So it is disjoint. So probability means that the union, probability of the union. If you take the union, now xn equal to 0, union x1 equal to xn equal to 1, dot 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 xn equal to d, this is the whole space, because there are only these are the state space. So xn obviously in between 0 to d. So that means your ith element is probability of xn plus 1 equal to I. What does this mean? That meaning this vector is nothing but this pi n p vector is nothing but pi n plus 1. Now go with the induction. Your pi 1, pi 0, p, pi 1 is like a geometric progression. So it implies actually pi n is nothing but pi 0 p to the power n. Matrix multiplication, matrix power. Pi 1 is pi 0 p1, pi 0 p. Pi 2 is pi 1 p, pi 1 is pi 0 p, so pi 0 p p p square. So we get this important result. To find the marginal distribution of xn, we need p to the power n. The transition matrix gives all these things. So in the previous example, to a two state Markov chain, what we get? We get, is to consider, assume in two state Markov chain. Assume that p plus q is not equal to 0. If p plus q is 0, then that means start from working state is always in the working state. Start from non-working is always in the non-working. P plus q equal to 2 means start from working, next day is non-working, next day is working, next day is non-working, next day is working. So these two are trivial, non-interesting case. So the interesting case is p plus q when greater than 0 and less than 2. Now, what is p? P, you can easily check p will be what? This p is given in the previous class. What is p? We start from 0 to 1. This is start from 0 to 1, 0 to 0 first, 0 to 1, then 1 to 0, then 1 to 1. What is the probability 0 to 0? This is given p or q. This is 0 to 0 is in truth state. Just let me check. From 0 to 0, it is 1 minus p. From 0 to 1, it is p. From 1 to 0, it is q. From 1 to 1, it is 1 minus q. Right. So this is the matrix. This is the transition matrix. And you can easily check that Pn by induction 1 by p plus q, q p, q p plus 1 minus p minus q whole to the power n, p plus q divided by p plus q, p minus p minus q, q. Just check for n equal to 1. Check it for n equal to 1. For n equal to 1, 1 by p plus q, q p, q p plus this is 1 minus p minus q by p plus q, p minus p minus q, q. So if you take 1 minus 1 by p plus q common, you will get q plus p into 1 minus p minus q. No, don't do this. No, don't do this. We can do more easier way. Sorry. Do like that. 1 by p plus q, qp, qp. This is actually 1 by p plus q minus 1. 1 by p plus q minus 1. P minus p minus q, q. This is plus no minus. Plus it is minus 1 by 1 plus 1 p plus q minus 1. So this plus p minus q, q. 1 by p plus q, take common this p plus q, this is 0, this is 0, this is p plus q minus p minus p minus p minus q, q. Then what is this? This is 1 0 0 1 minus p minus q. Oh, we get this. Got this 1 minus p what? Oh, this is 0. No, sorry. What happened? Yes, it's correct. Minus q, so 0 minus q, so q 1 minus q, right? 1 minus p q 1 minus q, right? If you take n equal to 0, what happens? If you take n equal to 0, you'll get the identity matrix. P plus q, then 0 0 p plus q divided by p plus q 1 0 0. So by induction, you can easily prove that p n plus 1 is use induction p n plus 1 is p n into p, and you can find that by induction this is the your matrix. So this is very important. Now for P and Q, if P and Q both 0, then what happens? If P plus Q 0, that means P 0, Q 0, both 0. In that case, we can't write that in this form because 1 by P plus Q 0 is undefined. Then in that case, it is homework, find Pn. What will be P? You just take P. What will be the P? P is, what is P? When PQ both are 0, it is just identity. Okay? P0, Q0, it is identity. So actually, it's easy, not homework. It is very easy. So P to the power n is identity. And you just, homework is P equal to 1, Q equal to 1. Both. That is your homework. Then it is, matrix is, in that case, matrix is, this is the case. Matrix is 0, 1, 1, 0. Then find P to the power. This is the homework. Now, next thing is M step transition function. M step. M step. It is one step, it is M step. Transition function. So what is M step transition function? So consider this, probability of x n plus 1 is equal to x n plus 1 dot 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 x n plus m, x n plus m small, given that all this x0 equal to x0 dot 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 x n equal to x. Now we know if present is given to you xn equal to xn, we can forget the past to find the probability of the future. But here is the future is something different. It is not xn plus 1 equal to xn plus 1. It is xn plus 1 equal to xn plus 1, xn plus 2 equal to xn plus 2. How to tackle this? So this is nothing but product. Okay, you know this is a product. This is intersection. Now this intersection, this, then x0 equal to x0 dot 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 xn equal to xn divided by probability of xn equal to xn. Now what happened? Is this a product? We can't get the product because this is not Markov chain. So we go with something like that. The probability of this is xn plus 1 is equal to xn plus 1 given the previous is the multiplication rule. Oh, sorry, not n plus 1, the m plus n, m plus m, xn plus m given the previous, all this previous, xn plus n minus 1 equal to xn plus n minus 1 dot 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 x0 equal to x0 into probability of the next one given the previous into that next one, into that next one, dot dot dot, and then last is probability of x n plus 1 xn plus 1 given xn equal to xn dot dot x0 equal to x0 into probability of the last thing divided by this. Xn equal to xn dot dot x0 equal to x. Why this is so? This using this result only, the probability of something, some a1 intersection a2 intersection dot 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 an, it is nothing but probability of an given an plus n minus 1 intersection an minus 2 dot 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 a1 into probability of multiplication rule dot dot a1, then something like that, and the last one is probability of a2 given a1 into probability of a1. This is easy. How can we find? You just go from the last one, a probability of a2 given a1 into probability of a1. This is just probability of a1 intersection a2. The previous one is a3 given a1 intersection a2. So probability of a3 given a1 intersection a2 into probability of a1 intersection a2, it will give probability of a1 intersection a2 intersection a3. So we'll get this. So that we used actually. The last one given the previous, then the next one given the that previous, and this we stop with here. You can go further. You can go xn plus xn equal to xn given xn minus 1 equal to xn. No need, because this will cancel out. This term will be cancelled out. Now what is this probability? This is clear, because this is clear because by Markov chain xn plus n plus m is equal to xn plus m given the previous is nothing but what? This is nothing but probability of xn plus m is equal to xn plus m given the just previous. No need to the others. Similarly, the next one is probability of xn plus m minus 1 is equal to xn plus m minus 1 given xn plus m minus 2 is equal to xn plus m minus 2 dot, 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 and the last one is what? This is last one will be xn plus 1. Xn plus 1 equal to xn plus 1 given xn equal to xn. Now these are nothing but the transition functions. Probability from x n plus 1 minus m plus n minus 1 to x n plus n. Next, it is from n plus m minus 2 to m plus m minus 1 dot dot x xn to x small xn plus 1. Now you can just write in the other reverse way, that will give better idea. Probability of xn to xn plus 1, then into probability of xn plus 1 to xn plus 2 dot dot dot. The last one is probability of xn plus m minus 1 to xn plus m. So that will start from m stage transition function, that is start from say 5 to goes 6 with 2 step 5 to 6. That means from 5 to 5, 5 to 6, and you have to add all this thing. Now you have to add all this thing. This is just, it is not the m stage transition function. It is just given that x0 equal to something something something, x5 say x5 equal to uh, 0, probability of x is equal to 1, x7 equal to 2, probability of x6 equal to 1, x7 equal to 2, given that x0 equal to something something, x5 equal to 0. That means from this 0 to 1, then 1 to 2. So it's a path. Basically, it's a path. In the graph theory, it is a path. Actually, it is a state space, some x0, x1, something like that, somewhere. So we start from xn. From xn, we go xn plus 1 with some probability. It's given by the transition function xn to xn plus 1, 2, and then last we get n plus 1. Now, if we just omit this thing, if we can find, we try to find this xn plus m equal to xn plus m, given xn equal to xn, or maybe the previous is not needed. If it is given the previous is same as just xn equal to xn. That means we don't know where xn plus 1. So we need all possible route to reach xn plus m in m step, all possible route, and we have to add all these probabilities. So here you need some graph theoretic idea. All for all such route, all such path with m length, and add all this probability. And each path actually the product of the small segment. How can we prove precisely? This is like that. The next step is probability of xn plus 1 is equal to xn plus 1 dot xn plus m equal to xm plus m, given that now x0 is not x0, x0 is belongs to some set. That means x0 belongs to x0 or x9, x10 is a set, is a collection of some points. Dot x n minus 1 x n minus 1, but the last one xn is just xn, single point. It is homework. You can easily check that. This is probability of, you can forget the past, xn plus m equal to xn plus m, given just xn equal to xn. Remember, what is this? X0 equal to x0 belongs to a0. This is nothing but this is a union of all x belongs to a0, x0 equal to x. This union of all such x. This a0 is a set, and take all the element of, remember this is a finite state. So a0 is a finite, so some elements are there. So some random variable belongs to the some set, means random variable taking each values and then take union. This is result, and this result you can check slightly calculative, because there is a union, then union, several unions are there, and union not in the this left hand side, is union the right hand side, given union. So you need to find what is the probability of this probability of, we know the probability of ai given b. This is, you can easily check, this is just union of, don't, no need of probability. Yes, it's probability. It is just, it is just what? It is probability of ai, then intersection b, given b, probability of b. Now, if these are disjoint, disjoint is needed. These are disjoint union. This is disjoint union, because all the elements are different. If ai is a disjoint, mutually exclusive or disjoint, then what happens? Then we'll get by this is the distributive law. Distributive law, we get xi intersection b, and then by disjointness If AIs are disjoint, then AI intersection B is also disjoint. We saw it in Bayes' theorem. So this intersection B, this, so we will get sum over probability of AI intersection B by B, probability of B. That means what is that? This is sum over probability of AI I given B. It just is the union formula for union. If it is a not disjoint, we need the minus probability of 2 at a time intersection, then plus 3 at a time. But here it is a different. Here remember, this is the union in the given condition. That means the probability of A given union of BIs. That is not just summation of AI A given BI, not that. You have to find what is this actually. So using that, you can find is a homework that this is just, you can forget the past. Intuitively it is okay. Once the xn equal to small xn is given, we can forget the previous past thing or the previous. Now union is this way. This probability of xn plus 1 belongs to an plus 1 in the some set. An plus 1, last one is an plus 1. Given that, oh, start from n, so it must be m. Given that, again, x0 equal to x0, dot xn equal to xn. Now we can easily check with this the previous thing, this thing, this one. Now union is in the left hand side, so not in the given condition. So it will be just probability of, just first break all these unions, then take the sum, then use the Markov chain property, then use again this sum convert to the union. So first union convert to the sum, then use the Markov property. Markov property will give you just xn equal to xn. Then again you have to use join this all sum into the union. Now the last one is this also homework. This is easy. Rather, the most complicated is this. If xn plus 1 equal to xn plus 1, dot xn plus m or xn fn plus m. Given that some a0 x0 in a0 dot a xn minus 1 belongs to an minus 1 and xn equal to xn. This is nothing but, this is the most complicated, most general thing. That means whatever this random variable takes values, it is a single value or a multiple values, given xn equal to xn, we can always forget the xn minus 1, xn minus 2, x0. This is the moral of the story. But you have to prove this all. This is the highly complicated. You need the previous thing to prove this. You can directly prove that. So it is nothing but what? This is nothing but sum over, you need a m sums. It's a single sum, with a single union, there is a single sum. There is a multiple union, so it is a multiple sum. So it is sum over what? Sum over xn plus 1 in xn plus 1 equal to xn plus 1 dot x n plus m equal to x n plus m, given xn equal to xn, but this xn plus 1 is a variable now, is can vary in an. So you have to run over all this xn plus 1 belongs to an plus 1 and xn plus m belongs to x. Now we know this xn plus 1 equal to xn plus 1, xn plus m dot xn plus m equal to xn plus n, given xn plus xn equal to xn. What is this? We know this. So it is just xn plus m belongs to a n plus m dot 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 xn plus 1 belongs to xn plus 1. This probability of from xn plus xn equal to xn to xn plus 1 equal to xn plus 1 given xn equal to xn and into multiply. We already prove it for this thing. This is nothing but the product of transition functions. It is a product of transition function starting from xn to xn plus 1, then transition function from xn plus 1 to xn plus 2. The last one is xn plus m minus 1 to xn plus m. Now this summation. You have to, this is outline. You need to fill up all these steps. There are several steps. Here is the most complicated part. Some maybe 6 or 7 steps. You need the fill the steps. Homework means every you have to fill up all these things. This is our outline just. So this is called transition function, m step transition function, m step transition function. What is m step transition function? This is by definition. This is by defined as xm equal to y from x0 equal. Start from x. After m step, you have to go to y. M greater than equal to 2. If it is 1, this is easy. Just transition function from x to y. So what will be the value of this? Now we have to use this the previous result. Now transition function at 0 step. Oh, it is easy. If x equal to y at 0, using 0 step we can go from x to y. If it is y equal to x, then with probability 1, and if x not equal to y, then obviously it is 0. Now, what was the 1? It is just easy probability of transition from x to y. Now what is m greater than 2? If m greater than 2, what will be this? M greater than equal to 2. This will be, now you have to use this result. You have to use it. You just fill up this all this an plus 1 by s, the state space, whole thing. We don't know where xn plus 1, so belongs to whole state space. Xn plus 2 belongs to whole state space. The last one is just what you have to replace. You have to replace with an plus 1 whole state space, an plus 2 whole state space, an plus n plus m minus 1 whole state space. The last one, n plus, oh, it is no, it is not n, it is 0, start from 0. N is 0 here. Oh, n equal to 0. We take n equal to 0 because we condition on x equal to x0 equal to x0. So n equal to 0 here. So this 1, 2, and the last one is m minus 1. M minus 1 is whole state space, but am is y. Y means the set continuum, only one element. And if you put this, what will get? You'll get some summation over all these x1, x2, xn. So you'll get, this is nothing but somewhat from x to y1, then y1 to y2, this is the path, then y2 to y3 up to y m minus 2 to y m minus 1, then from y m minus 1 to a y, the last one is y. But this y1, y2 can be anything, all possible paths. So we have to sum over all this belong in scriptures. This is the m stage transition function, and you can easily check. In next class we will check this transition function is nothing but the matrix of this transition function is just the matrix p to the power n. This is not p to the power n. This is just notation. P is a function. Here P is not a matrix. Remember, here P is not a matrix. This P is a function. P to the power m is not a P to the power m. Pm, like f1, f2. It is not function to the power m. It is just Pm is a whole function. We can use any other thing. We can give some bracket. We can take Pm as subscript. It's like a script. It's not function to the power m or matrix to the power m. It is a function. P is a function. Pm is another function. And the matrix correspond to the P. If it is say P, it's a Q, okay? And matrix correspond to the function Pm. If it is some R, then R equal to Q to the power n. So matrix correspond to the Pm is actually the mth power of matrix correspond to the P. That we have to prove, and we will prove in next class. For today lecture is up to this.